catch-ups in Sprint 1, which started last week and will conclude this week. So yeah, let's get right into it. About Sprint 1. Sprint 1 was all about putting together all the things we learned in the initial weeks of the research lab program. And so that included like the first drafts, the literature diagrams, thinking about solutions from a more holistic viewpoint. All of that hopefully went into Sprint I and what you was building. And so, yeah, the goal was to have a thin but fully connected version of your solution with the core logic that we've been discussing in our various catch-ups and group calls um, to an output, minimal but real integration with data sources wrapped around a CLI or simple UI if you could feasibly do so to trigger the workflow or to trigger the agent execution depending on your research task. Obviously, I have some examples there of what a UI might look like. On the right is Streamlit, and on the left is I think it's a Figma example. I took it from a template on Figma, but those are some examples of UIs that you potentially could have implemented. But it's fine if you didn't implement a UI or anything, but that's kind of the direction that I want us to go towards. So yeah, that's Sprint I in a nutshell. Obviously, you guys have been working on it, so you'll know anyways. But what does an end-to-end solution look like? I've said it a lot. You've probably seen it in the schedule, some of the other material I might have sent you. But an end-to-end solution basically comprises of a few core things. Firstly, core functionality. It takes a user input, a data point or a trigger and some sort, and then returns an output reliably. Um, Deterministic and well-bounded behavior is a common feature of an end-to-end solution that we would consider a safe end-to-end solution, especially when you're talking about AI agents or anything involving AI. Having a well-bounded behavior for your AI system is very much useful and an effective way to monitor its performance. I left the example there for Joel. For instance, you don't want your prompt compressor to have the ability to remove all the characters in the prompt. So hopefully there would be some sort of guidelines there to allow that or to stop that from happening. Secondly, seamless integration. So APIs, all the libraries and frameworks you're using work together reliably with your internal algorithms or code. That's standard procedures. User experience, clear input and output interfaces. So as I talked about earlier, UI is very important. How are you interacting with it? How might other people interact with your solution? Meaningful error messages, feedback loops. A feedback loop is basically how is the user's data being used to refine the process or your tool. So like a common feedback loop you might encounter in AI chatbots. Under the hood, they're using your conversations to obviously improve the quality of their responses. And so they're looking at things or they're implementing things like feedback. So thumbs up, thumbs down, or they're using NLP to try and understand your responses and try and improve their own responses to your user queries. So that's a kind of common feedback loop. Observability and monitoring is the last point that we'd consider important for an end-to-end solution. So things like logging, inputs, outputs, errors, metrics, such as latency, throughput tokens. If you're keeping track of this in some structured way, then I'd say you have a good grasp of what an end-to-end solution should look like. Two images on the bottom. Prompt Trace is a solution that we worked on most recently for our AI chatbots and our image generator. So prompt trace basically wraps around any sort of LLM or agent calls in Python, and then it tries to read the inputs and outputs. And so it allows us to keep track of what's going in, the latency of messages or LLM calls, the number of tokens. And it's also good for various use cases, such as evaluating the quality of responses and more. So yeah, that's an example of how you might implement monitoring around your own solution. And so on the right is our chatbot in which we use prompt trace for. So yeah, that is what an end solution looks like in our opinion. But over to you guys. So I'm gonna ask any of you to kind of just step forward and start presenting what you've kind of worked on in the past few weeks. And it doesn't have to be fully complete end to end, even though that's what we discussed, but no worries. Whatever you have, I'll be happy to observe, and we can all kind of discuss and ask questions about if needed. So is anyone interested in going first or stepping up? If not, I can, I guess, I can ask one of you. Syed, you can go first. I think we had a discussion last week, and he was quite optimistic to show what you've been working on or you talking about it. So, and
Yeah,
I didn't forget, I haven't forgot. You asked about the email. Sorry, we can talk about that after the presentation.
yeah, it's okay. And tell me, before going forward, I'll just send the link on the chat, and you'll just go and kindly open the link on your PC and try to test my baby at first, and then I'll just show you,
Okay,
explain you the overall scenario behind that. Okay?
sure. Um, yeah, you can send the link here. Yeah, a nice interactive demo. Nice. Um, so I press enter. I see. Enter baby AI.
Yep.
Nice, nice. My
Yeah.
computer is really slow, so it's not your app. It's my computer, if anything.
That's
So
fine. That's fine.
so what do I do
Yeah.
first?
Just think like it's a baby,
Okay.
and you are
Um.
his father or something else, like you're his friend or anyone.
Okay. Uh, hello. Does it have a name? No.
Yeah. Just
I was gonna ask what is your name. So yeah. Who are you? I am your reader. Nice. I like the UI. It's very
yeah.
cool.
Basically, these are the neurons firing in the brain. It's the actual mechanism behind the baby eye, as I told you in the last meetings.
Okay. So what's happening here? I can see memory growth. What does that mean?
Yeah, basically, last in the last meeting, I told you that I'm going to go with the three kind of memories. First is the word memory. It know about the words. This is Tammy, this is Kumail, this is this word, and this kind of stuff. This is a car. I mean the entities within the world. He's basically learning in the world chart. It
Yeah.
grows, and for the self, he know about himself. He's building his own identity. I think so. It's the UI. Basically, just because of the laptop screen, the self identity is not fit very correctly. Otherwise
Mm.
you'll see the chart of his own personality as well. How much curious he is, how much scientific approach he's using, how much storyteller he is, and this kind of personality he will. Basically, this chart will show you. I'll show the same thing on my PC as well. But after your try, after your trial, okay.
Yeah.
And the
Okay.
cognitive basically these are the cognitive dynamics. As you do the chat, he will find that the dopamine level and the novelty level in your chat, in your every text message.
Okay, that's interesting.
And then the last thing is the kinship and bonding. As you see that baby AI with the user is the child.
Yeah.
Yeah, because you are the creator.
Okay, okay. Let me see what happens to the
Yeah.
dopamine
Yeah, basically
and
it's
nothing.
something very new for him, so that's why his novelty is always hitting.
Okay, let's try bring down the dopamine then. What do you think I should say like to try and bring down the dopamine?
Just say the same thing again. You'll see
Okay.
that the drop in the novelty.
More than your parent. Yeah, that's what I said last time. Let's see how okay.
it will take time. Yeah.
It dropped a
uh,
bit.
yeah, it's same, it's okay. When he understand the context, it will become you know I'll show you the chart on my PC as well. uh,
Yeah. No worries. I think I understand how it would work, and
and
maybe it's not me.
one more important feature in this, in this, is you will see that mode turns.
Mm.
Basically, it is something like, if you shout on him, you will see that the balance score will go down, and this baby will start crying. Right now, he's smiling.
Oh, okay, that's nice. Let's see.
Yeah, on the check on the balance score and the arousal. Yeah,
Yeah.
yes,
Okay.
yeah, it started crying. Just tell him like, shh, I'm here, and this. Just try to.
I'll try and comfort him then. Yeah.
Yeah.
No, I'm here. Don't worry. See what happens.
Yeah, you see that.
No.
He's now just soothed, not smiling. He's just soothed, and if you again tell him that I love you and this kind of, he started smiling and this kind of stuff.
Yeah, that's very cool. I really like that, and I like the UI as well, the visualizations, all these different metrics. It's very cool. Very
Yeah,
cool.
and you can check every node of this his brain as well. You'll see that the connection. You just go on any of the node.
Okay. So
It's
well,
the self, he himself. He's building his own identity. Apology. He understands something about apology.
more than a parent world entity. Okay.
You'll see the connection. Just check that there is a connection between the more than the parent and something, the user. You
Yeah.
are saying every time this same thing.
Yeah.
So he built a strong connection. You see some of the lines are a little bit yellow,
Yeah.
and some of the lines are it's these are not very dim. Basically, it shows that how much important this thing is to that person. With the time, as you know, we have the decay function. Over the time, it will fade. These connections will fade as well, as like in our brain.
Yeah. Right. Right. Like how we learn things over time. Right. I
Yeah,
understand that. Okay. That's very
you
nice.
see, the chart novelty.
The chart novelty. Where is that? Sorry.
Yeah, yeah, cognitive dynamics.
Oh, yeah.
Novelty go down.
Yes. 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 It's gone down. It went down earlier as well. A
Yeah,
lot.
when I think so,
When
you said him that he shut up. Like, yeah.
yeah. Cool. That's really nice. I was really impressed with that. That's really good. Can I ask you a few questions? And I think everyone else
Yeah, yeah,
might want to ask a few questions as well. Firstly, where are you hosting this site?
yeah. Yeah,
Yeah.
right now, in just basically, I'm not the web developer. I just made this app with the Emergent, and I was trying to copy all of the code and try to deploy on my own web server, my own domain, about the AI Academy. I'll just
Yeah.
take a slash and just say that it is a baby. I was trying to do that, but it was not connecting with my GitHub for now. So that's why I just give you the demo link on the Emergent.
Oh, okay. That's fine. Secondly, what model are you using for the actual chat? So
Yeah,
like, yeah.
for just doing the chat, I'm just using the OpenAI 5.4 version.
Okay, nice, nice. All right, I
Yeah,
could ask more questions, but I'll just leave it to the rest of you guys. Saksham, Joel, if you guys have any questions.
yeah, no worries. Yeah, if you have any other kind of question, you'll just send me the. You'll just contact me on the Discord. I know I always do delays in the doing the replies, but
I think they might have
just
some questions now. So
yeah, it's,
I guess you experiment. What have you found increases spikes the dopamine the most, and what decreases the novelty? And also, does the amount I'm assuming that at the start the dopamine and the novelty can fluctuate the most. Yeah, does it fluctuate the most at the start and then eventually go down as more, I guess, neurons and connections get made?
Yeah, basically it is because at the very first everything is new for the baby. Everything, each and everything, every word is absolutely new for the baby. As Tammy told, that I'm more than a parent. I'm here, don't worry. Everything is absolutely new for the baby. That is why the dopamine always hit the novelty. He finds the novelty in the text always. But over the time, you just check the last note, the dopamine slightly down, and with the time it grow the mind, it know about the things. It will the dopamine will hit only on the specific things, like the things he loved the most, or the things that is very enriched with the novelty features.
Nice.
Yeah, makes sense. Nice.
Any other question?
I think that might be it, unless Saksham has one. Coming up. But yeah, nice work, Syed. Very impressed with what you've come up with here. But yeah, if
Thank
you guys have any questions for him, yeah, definitely do shoot my message on Discord.
thank you. Okay.
Okay. Joel, Saksham, do any of you want to go next?
Yeah, I mean, I can go next.
Sure. I'll stop sharing
So,
my screen if you want to share yours.
okay. All right. So, since the last time I've been working on some edge cases, I believe that there were some cases where I wanted to reduce the possibility of any errors and make the score more dynamic in my demo that I was having. So over here, I have been adding some functionality such as manual override, where it's possible for a user to also be able to methylate certain events on their own, because right now I'm looking into the next steps to convert this into a user editable configuration. Basically, I'm looking to turn this into an API or some kind of app where we can add the LLMs and the specific context and prompts. And basically, this system can start creating a wrapper around multi-agentic systems, and it can help with the methylation, the memory, and all those other things. And a user might also be able to look at certain hallucinations or certain parts of it that they don't like, and they can manually override. So over here, I'm having some functionality to begin working on that. Also, same as before, I'm having all the metrics over here for all the updates that I'm making. So since then, I have, like, rather than just doing a binary decision, I have split this off into neutral affinity, low importance, expressed, and other parts, so that it's easier to understand the difference between certain kinds of events and do some analysis on these. And the gating threshold is right here that we're using for the importance. So basically, this is all to make sure that when different agents are working together, every agent is only accessing the memory and the details that are important for its own specific role, and everything else that's not important is getting methylated, and also all the hallucinations and other errors are getting methylated. What I'm working on next, as I said before, is working on some memory snapshots through semantic compression. The challenge over here is that there's already the L0 level raw causal log that we have, but that memory can often be very detailed, and it can actually make the memory increase a lot, because we have recently seen some cases, especially with very good AI systems like Claude, that even just 5 to 10 messages are expending its entire context budget. And that's a really big issue, especially when we get into multiple agents working together, that we don't have enough tokens, or we don't have the budget to maintain very long conversations in which we're working on very complex tasks. So what I've started implementing, and here is example of that, is First of all, we have like just a raw causal log of exactly everything that's happened. And then after every 10 events, then we have a L1 snapshot, which is sharing a current phase. So rather, and that actually follows the biology of the human mind, because we as humans tend to take every small detail, but we don't remember everything. We actually compress all of the memories of, like, let's say, one conversation or meeting with a person into one summary and one comprehensive phase, which makes it easier for us to relate all those things together and make it more coherent. So right now I have the L1 snapshot here from 10 different events, and then here's the L2, which can be used by the human or at a higher level when we are, let's say, working 2 or 3 months ahead. So basically, this is helping us compress all of the details of what is happening. So as you can see over here is that, let's say, this phase involved these different agents collaborating on 10 events, and then what were they focusing on and what was the key consensus point or something like that, so that we are knowing how these multiple agents are actually collaborating together and what they are resulting into. And at the L2 level, they are again creating a very short summary of all the major things that happened. This is uh, a short one because nothing has happened, but it could be something like maybe the agents have come together and they have found a hallucination, or they have come up with a new plan to execute. And that actually helps a lot, because as we go back into like 100 events or more, then it becomes very easy to use these strategic chapters to quickly update the LLM with the context of everything that has happened. And it makes it much more easier to reduce hallucinations and reduce the token cost, while ensuring that the agent has access to the perfect context. So this is actually something that I'm working on into how I can do the semantic compression. And since I'm already working on manual human in the right systems, my next step right now is going to be integrating it into an actual LLM agent system. I've also been looking theoretically into all the mathematics and all the details about how this is going to play in the real world, because it's not just about, I would say, getting the demo right or like getting an app that works, but also about the real world impact. So I've actually taken all my research and even like drafted a research paper on this, because I think I had already mentioned to Temi that I was interested in a research implementation. So I created this idea of the of the agentic trilemma, where I said that the autonomous AI cannot be fast, free, and accountable at the same time. And I'm saying fast because there's some latency that is involved with this particular system that I have implemented here. And my aim is that to keep this within 5%. So I'm sharing a problem over here about the consensus and the latency, as well as the hallucinations and unreliability of agentic systems if we use them at scale. And over here, all the solutions that I'm sharing are actually related to the project that I'm building over here. So I've submitted this to Nature Machine Intelligence about a few days ago, I believe past week, and getting this foundation in place. Now I'm looking into all these different ideas and converting them into practical methods, so that I can start finally implementing this into a real system, an API that I can open source and maybe post on X and other places to get other people to use.
Sorry. Yeah, I was muted. Yeah, sounds great. I do recall you saying something about the papers. And so I did try and look into it, but it's something I kind of I'd thought I didn't want to distract you guys with that. So but definitely worth sending that paper to me, and I'll have a look as well.
Sure, definitely. I'll share that with you. I'll share this draft with you.
Yeah,
Yeah.
nice. And so I think next steps for you, clearly, since you've already kind of got it like theoretically kind of like sorted out, and you know what you're trying to figure out, you have your solution, is to think about your kind of like your deployment, or what your how you're going to have other people test it and share it with other people. um so yeah, I think you're already thinking about that, so there's not much left there to say. But yeah, a very good sprint for you, I'd say. Then when abouts did you start writing that paper?
Actually, I started it in very short duration. I actually just have like all of these different ideas, and school is generally taking away time to implement things. So I just like
Mm,
took a weekend to myself and actually started from scratch on three different research papers and like published them all in that weekend itself. So this was actually one of the papers where I understood that currently there's a reliability issue in these systems, and that if we use distributed systems and all the consistency frameworks that we already have, but in a unique way, then we can solve that. In this paper, I actually didn't consider the extra things about like the memory methylation gating and other things that I'm already implementing in mine, because I believe that that would be like trying to solve too many problems or sharing too many
yeah,
different ideas in one place. But yeah, this was basically like the foundation of my research as well. And yeah, I mean, soon I'm also like, I already have a repository with me, but that is private because I'm still making changes. So soon I'm going to actually integrate some LLMs into that and maybe create some kind of system where maybe a different repository with LLMs and agents. And basically it can connect to that repository as an API, and then it can very easily fit into like, ideally it should be model agnostic and framework agnostic. So it works with LangChain or any other library, and it creates like that dashboard that I just showed you. The UI can definitely be improved and made better. Really did like the UI that I saw before me. So I would like something like that in place that can actually show all those metrics being generated in real time. And
yeah.
yeah, so that's going to be the next step.
Okay, yeah, sounds great. Does any of you have any questions, Joel, Syed? If not, we can continue.
Actually, not right now.
Oh,
Mm,
right. Just
because
think a bit
we do
harder.
we do not have any idea, lot of idea about the yeah, hallucination in the AI agents. That's why I'm just learning about these kind of things
Sure,
from
sure.
this
Makes sense.
session.
Makes sense. Makes sense. All right. In that case, then, thank you, Saksham. And yeah, definitely do send the paper as well, so I can have a read. It was very nice to see that. Um, Joel, you can go next, I guess. Well, you have to go next, but
Yeah. Um, yeah, that's not the problem. That just trying to reduce token cost for inputs on quite dense prompts, a lot of system prompts, and I guess where AI is probably used by the less technical people like customer service or maybe sales. There's a lot of redundant text in it that can be compressed people aren't so that people don't drive up their API pricing and costs. And the last in the last I guess meeting, I was talking about my informed Bayesian optimizer, where now that I've done some data analysis on a data set of test prompts, I found, I guess, a pattern and ideal structure of prompts. Now, and then I actually implemented my Bayesian optimizer. So what the optimizer does is that it generates a search space. Um, it generates a search space, looks into the search space, and since it's Bayesian in nature, it updates what it's seen based on the outputs. And it continues searching until it finds the ideal prompt structure that balances output and variance, so how far it is from our original prior or just information in the data set. And from the results, you see that there's a 17.5% increase in performance compared to the naive prompt compression where we didn't use the P3 pliers, and also compression generally saw like 6 to 7% increase, showing that it took the same amount of time, though, the same amount of search runs, which was 25, but we were able to find a better structure, and that's purely because we started in a better position in the search space. Um, Also, I found a couple of new data sets because I just wanted to check the generalization of this prompt compression. And it's interesting to see, it was a mix of P3 and I think some system prompts. For shorter prompts, generally it didn't compress well at all. For medium-sized prompts, we got around 10 to 23% compression. And then for the largest prompts, it was anywhere between 25 and 43, which is pretty good. But what's interesting, my initial hypothesis is that the longer the prompt is, the more it could be compressed. But there was specifically one example. My presentation is not in a very good order. There was one example that had 547, I guess, tokens, but only compressed by 3%. Oh, here it is. Yeah, it had 547 tokens, only compressed by 3 or 4%, which I guess made me come to the discovery that it's not about token length. It's not about token length in terms of the best performance for compression. It's purely from redundancy. And I'd say the most of this sprint has been thinking how to go about, I guess, now testing if it's even safe to compress a prompt, because if it does contain a lot of key information, should we even be compressing it? And also for the medium-sized prompts, how can I go about getting it from, I guess, that 15% compression to much closer to, the 30-40% compression that I'm getting on my best performers. And yeah, in terms of what I've been thinking about is to use information theory to test whether it's even safe to compress a prompt. So you compare how much you are, there's this formula where IT of Y is how much task information we will have preserved after compression, and IX of T is how compressed we are. And the goal is to maximize the task information and minimize how compressed we are, and we'll end up with a trade-off parameter to see if tasks are even worth compressing. Also, for the medium-sized prompt, I'm looking at semantic compression. So using NLP to compress it. So right now, I guess I'm reordering the structure and removing irrelevant pieces of text that don't add any value, that don't add any context. With the medium-sized prompts, it's relatively dense already. So I was thinking, what if we use natural language processing to condense it, but still keep the same semantic similarity? And this, obviously, initially I thought, okay, we could use an LLM, but it kind of defeats the purpose of trying to compress LLM outputs by using an LLM to compress it. But LLM framework, it will be much cheaper and it will be much faster than an LLM, and it still serves the same prompt compression purpose. And something I've really been thinking about is, attention-informed priors. So right now I've been looking at the priors that I've been using is based on data analysis. But I was thinking, what if I use the actual attention weights that get calculated in a transformer to see which components are the most important in terms of the final context? Because the attention mechanism is that you compare the similarity between, I guess, the query and the key. And then depending on the similarity, we add that much of the value to the final embedding. And obviously, it'd be really bad if I'm removing values that have high attention weights, like examples that have high attention weights and provide a lot of context. I got this idea from, I'm not sure if you guys seen the research on where someone when they paste a prompt in twice into like any large language model, they'll get better results because the attention can attend to two different positions and embed more of the most relevant information in. So I've been really looking into the maths of how to actually make this work, and I think it'd be a really good research contribution. Mm, And then another thing that I've done is that now that I've got, I guess, my average model performance on different kinds of prompts, um, and using the informed optimizer, I was actually using it to calculate how much um, environmental impact we can reduce, which is yeah. And the outputs are in dollars because that's I'm using the OpenAI estimation of how much carbon they're gonna produce per prompt. So assuming that we're like a medium-sized enterprise that making about 10,000 requests per day, we're saving roughly 71 tokens per request, 260 million tokens per year, and then yeah, that's an annual cost reduction of 2,500. Oh, annual cost reduction of 2,500. And yeah, we're ranging anywhere between 150 to 250 kilograms of CO2 that could be avoided from the token reduction. Yeah. So yeah, that's to summarize what I've been doing. And then for the next 3 weeks, I'm going to be trying to implement the NLP so that I can improve the reduction on medium-sized prompts, looking into if the attention informed prior is actually a valid route to go down further into the actual code implementation and the information theoretic framework, because we don't want to compress if it's not even safe to, if we're losing too much mutual information.
Yeah.
Oh, and in terms of deployment, I'm looking at deploying it as a library that people can put as they can use it as a medium layer in between the actual passing in an input and sending that input into an AI API.
Oh, okay. Great. Sounds great. My first question would be, what was I gonna say? The NLP approach you're using now, obviously you say you didn't want to use an LLM obviously because that would be like counterproductive, but isn't there sort of a cost, a compute cost of using an NLP model as well, similar to using an LLM, of like reordering a prompt, or let's say you have an algorithm for like removing stop words, for instance, there's still a cost to using that NLP method. So like, could you shed some light on that? On like what exactly the NLP methods you've like discovered, or you're kind of like probing around? Which ones are you most interested in, and why?
Yeah. So in terms of cost, well, I think one of the main ones I was looking at is text rank. In
Yeah.
terms of like compute, so if this is going to be an intermediary layer, how fast are we going to be? Like, we don't want it to take loads of time. I know that text rank takes around 10 to 20 milliseconds on a CPU. So in terms of deployment, it's good for that. But I do need to actually, once I make an implement, yeah, I need to look into the compute, because it's also, is the increase in compute going to be worth the extra compression? It's a trade-off. So yeah, that's a good point. I was mainly thinking about deployment.
Okay. Yeah, it's just something to think about, really, in it. But I guess what you'll do now is you kind of look into it and test and see if it's worth it. So yeah, nothing really too serious there.
Yeah.
Yeah. Apart from that, do I have any other questions? The cost reductions are cool, but what I was thinking was like, once, let's say you're a business and you like, or you're a developer working for a business that uses a lot of LLM calls, you probably only use that library a few times. You might make a few prompts here and there, but like, let's say you have a prompt that you use for one task and you only use that prompt.
Mm.
Once you use the library once, then technically, would you have a use case for the library again? Unless you're constantly making changes to the prompt and then you'd call the library again. Is
Yeah,
that
I'm sure that with the landscape, I mean, people are integrating AI more and more into their different workflows. So I'm
yeah,
sure there will be eventual use. But for even if they do use the library a few times, the cost, I guess, yeah, they get the benefit from the cost reduction, and there will still be that environmental impact.
yeah,
So
of course.
yeah, so I guess it's bad for me, but it's good for them and the environment, right?
Yeah. I get you. I get you. No, that's cool. We don't often think about the environment, especially when working on AI projects. But yeah, I think there's one fact about how like one like message is like. Let me not spew misinformation, but it uses a lot of energy. I'll just say that.
Yeah, I
But
definitely feel like there's lots of news on it, right? And I feel like it's whichever party is going to try and make the other sound worse or themselves sound better. So
mm,
like even I don't think there's even official OpenAI figures on it, because it varies, right? It varies on the
yeah,
model, it varies or, the input. Like, does it require RAG? There's so many different
yeah,
factors.
it's true.
Mm, but
Yeah.
yeah, but no, there are some scandalous numbers out there.
Yeah, definitely. So I might look into that. But no, yeah, thank you, Joe. A very nice presentation. And so yeah.